Keycap 2: The 4 ways to define. What is AI? 4 o'clock to 9 o'clock. Here's something interesting. Over the decades, researchers actually split into 4 different schools of thought on how to even define intelligence in a machine. Let's go through each one, because exam questions love this topic. A. Acting humanly, the Turing Test approach. In 1950, a brilliant mathematician named Alan Turing asked a simple but powerful question. How do we know if a machine is truly intelligent? His answer was the now famous Turing Test. Imagine you're typing messages to 2 different people in separate rooms. One is a human, one is a computer, and you can't see who's who. If you genuinely cannot tell which one is the machine just from the conversation, that machine passes the Turing Test. To actually pass this test, a computer would need several abilities: natural language processing, to chat with you in your own language; knowledge representation, to store and recall what it has learned; automated reasoning, to answer questions and draw new conclusions; machine learning, to adapt to new situations and spot patterns; computer vision and speech recognition, to see and hear the world; robotics, to physically move and manipulate objects. This single test basically sketched out the entire roadmap of what AI needed to become. B. Thinking humanly, the cognitive modeling approach. This approach says, if we want a program to think like a human, we first need to understand how humans actually think. Scientists do this through 3 methods: introspection, literally trying to catch your own thoughts as they happen; psychological experiments, observing how people behave in real situations; brain imaging, scanning the brain to see which areas activate during which tasks. Once researchers have a precise theory of how the mind works, they try to turn that theory into computer code. This overlap between AI and psychology actually created a whole new field called cognitive science. C. Thinking rationally, the laws of thought approach. This is the more mathematical, logic-based approach. The idea is that there are fixed laws of thought, like the rules of logic, that represent correct reasoning. If we can encode these logical rules into a machine, it should be able to reason perfectly. But this approach hit 2 big roadblocks. It doesn't work well when we don't have 100% complete information about a problem, and in the real world, that's almost always the case. Even simple problems with just a few hundred facts can completely overwhelm a computer's processing power, because pure logical reasoning is computationally very expensive. D. Acting rationally, the rational agent approach. This is the approach most modern AI actually follows. Instead of asking, can it think like a human, or can it follow perfect logic, this approach asks something more practical. Does the machine take the best possible action to achieve its goal, given what it currently knows? Picture a self-driving car. It constantly senses its environment through cameras and sensors, and it acts through its steering and brakes to safely reach its destination, even when the situation is uncertain, like sudden rain or a pedestrian crossing unexpectedly. That's a rational agent. This approach is considered the most powerful because it's mathematically well-defined, and it doesn't require the machine to copy human thinking exactly. It just needs to make the smartest possible decision with the information available. This is the foundation almost every modern AI system, from Google Maps to ChatGPT, is actually built on.